In this video, I'll introduce blood vessels, and we'll look at their function, how they are named, and a little bit at how they are built, the way that they are constructed. Excuse me. So, blood vessels have the function of first conducting blood from the heart out to the peripheral tissues, and their job is, during this transportation phase of their function, is to prevent the loss of any of the materials that are being carried in the blood. And then once they get to the peripheral tissues, their function shifts from preventing the loss of anything from the blood to allowing the exchange of any nutrients, the dissolved gases that are in the blood, the wastes that have been carried in the blood, hormones, and all the other things that we've talked about blood transporting. And it allows that exchange between the fluids of the blood and the fluids of the interstitial, the fluids of the tissues out there, the interstitial fluids, the fluids that are found in between the cells. And so, first we got to get the materials to the place where they're needed and can be used, and then we have to allow those materials to get out of the blood vessels and into the fluids. Arteries are the largest blood vessels that conduct blood away from the heart. So these are efferent blood vessels. The arterial system is efferent, conducting away from the heart. And the arteries of the heart originate at the pulmonary trunk and from the aorta. So those are the two largest of the arteries that are found in the body, the aorta and the pulmonary trunk, and all of the arterial system emanates from these two main blood vessels. As they get farther from the heart, the arteries branch and branch, becoming smaller arteries, until eventually the construction of the vessels has changed enough that we refer to them as arterioles. So if this is the construction of an artery, here's an arteriole, and the arterioles conduct blood from the arteries to the capillary networks. Capillaries are the very smallest of blood vessels. Here's a cartoon of a capillary. Their diameter is just a bit larger than a red blood cell. So there's just enough room for one red blood cell to pass through at a time. And if you look at video of blood vessels, of capillaries that are pumping blood, you can see them, the red blood cells all line up and they go through one at a time. And these are the vessels then that are leaky, that allow for the exchange of chemicals and gases and other materials between the blood and the tissue fluids. And you can see here, they're showing how they're leaky. There's little gaps, little gaps, there we are, there's one, here's another one, that allow fluid to leak out of the blood vessels and fluid to leak back into the blood vessel, depending on where it is in the capillary network. On the far side of a capillary network, then, we return the blood to the heart, and veins are the very largest of the blood vessels that are returning to the heart. But we have to build a vein by merging small blood vessels together. And those smallest of blood vessels on the far side of a capillary network are the venules. And so as capillaries merge, they form venules, and these venules conduct blood away from the capillary network. They merge, forming larger and larger venules until eventually their construction resembles what we refer to as a vein. And the veins then conduct the blood back toward the heart and terminate, they end at the heart as the superior vena cava, draining blood from the head and from the arms and shoulders and the very uppermost parts of the thoracic cavity, or the thoracic portion of the body. And then the inferior vena cava, which drains blood from the legs, from the lower parts of the trunk toward the heart. And then coming from the lungs, we have the right and the left pulmonary veins that are relatively large. They're much smaller than the inferior and superior vena cava, but the pulmonary veins bring blood from the lungs. So here's something that's really, really important. I want you to keep this in mind. Blood vessels are not named based on the oxygen content of their blood that they're carrying. Because let's take a look at it. So in the systemic circulation, so this is blood that is leaving the left ventricle, and in the coronary circulation, also blood that has just left the left ventricle. The arteries are carrying blood that's rich in oxygen, and it carries the blood out to the tissues. The tissues will take up the oxygen and will release carbon dioxide into the blood. And so the veins that are returning to the heart are carrying blood that is depleted in oxygen. But in the pulmonary circulation, this is the right side of the heart, the blood that is leaving the right ventricle, because this is blood that has just been out to the body and has not yet been to the lungs. The arteries, the pulmonary arteries that leave the right ventricle, are very poor in oxygen, depleted in oxygen, and relatively rich in carbon dioxide. And the veins that return to the left atrium, they are rich in oxygen because they're coming from the lungs and going back to the heart. So this is a reversal from what we learned in elementary and high school about what kind of blood the arteries carry. We generally think of arteries as carrying oxygen-rich blood, but the pulmonary arteries are a reversal of this. So keep that in mind. Okay, so how are blood vessels built? What's their construction look like? Well, they come in three distinct layers. There's the tunica interna, that's the innermost layer, right here. There's the tunica media. This is the relatively thick portion of the blood vessel, whether it's an artery or a vein. It is the thickest layer. And then the tunica externa. So three layers, and we see those three layers whether the vessel is an artery or a vein. So the tunica interna is the smoothest innermost lining of the blood vessels, and it's composed of a tissue that's named endothelium. That's a simple squamous epithelium, and it has an underlying basement membrane that's built of irregular, dense, irregular connective tissue. So it's built of these collagenous fibers with fibroblasts in there kind of tending to it. And it provides a supportive layer that is able to hold together the very delicate, simple squamous epithelium. And there is a secretory, we think about epithelia as having a secretory function. There is a minor secretory function here. They secrete chemicals, the cells, these epithelial cells, secrete chemicals that help to inhibit blood coagulation from occurring, so that platelets don't begin clumping, and we really limit the risk of forming a blood clot. And so the real function then of this endothelium is to allow red blood cells and platelets to slip through the vessels without sticking or being damaged or forming any kind of blood clot. The epithelium also secretes chemicals that can either dilate or constrict blood vessels. So NO gas, that's called nitric oxide, is a smooth muscle relaxing neurotransmitter, and so it encourages the relaxation of the blood vessels and a lowering of blood pressure as a result of that. So that's the tunica interna, and all blood vessels have tunica interna. sometimes called tunica intima. Think intimate, so it's an intimate association with the blood itself. Tunica media is that middle layer, and it's composed primarily of smooth muscle tissue with supportive collagenous and elastic fibers. So especially in arteries, but in veins too, there's a lot of elasticity to the blood vessel. Those smooth muscle fibers are arranged so... There we go. Sorry about that. So if this is the length of the vessel, they're arranged so that their long axis is around the blood vessel, so that when, if you were to look at it, you'd see sort of the grain going like this around the blood vessel. And when the smooth muscle fibers contract, then that will constrict the vessel, causing it to become smaller in diameter. As they relax, then the stretched elastic fibers help to snap or pull open the blood vessel diameter. So we see dilation. And be careful with your spelling of dilation. This is dilation. Some folks like to stick an extra A in there. So it's not dilate, it's just dilate. And it sounds like, if you say it really quickly, it sounds like you're saying dilate. So I get it why people get that confused, but do your best to remember this. We see that these muscle fibers are under control of the sympathetic division of the autonomic nervous system. When we stimulate these neurons, it causes contraction and vasoconstriction, and they're always a little bit stimulated. When we inhibit these neurons, then that inhibition allows relaxation and vasodilation. So vasoconstriction, vasodilation is under control of sympathetic division of the autonomic nervous system. And in arteries, we see that this muscular layer is thicker, and this is all about allowing the artery to resist the high pressures under which arterial blood is being pumped. So arteries have much higher blood pressures than veins do, and if we didn't have this thicker muscular layer, then the artery would be very likely, much more likely to develop an aneurysm, to blow out. Okay, so that's tunica media, the muscular layer. And then last of all is the tunica externa, also sometimes called tunica adventitia. This is a relatively thin layer of connective tissue with elastic and collagenous fibers that surrounds and kind of holds in all the materials that build the blood vessels. And its real function is to hold the blood vessels in place where they are. So it's the construction material that helps to anchor the blood vessel where it's supposed to be. Okay, so 3 layers: tunica interna, that's the slippery layer that allows blood vessels to slide along; tunica media, that's the muscular layer that can constrict and relax the blood vessel; and tunica externa, that is the wrapping that holds everything in and anchors the blood vessels where they are. Okay, so there you've got it. You know what to do if you've got any questions.